Here's a video on the factoring and roots quiz for anybody who would like this to study from. Now I've left the definitions up, my basic definitions for what a factor and root are. A factor is something that divides in evenly into something else, and a root is a zero or an x-intercept. Root could also be described as the point where a function crosses through the x-axis. Any of those would be fine. Now factor each polynomial completely. This right here has 4 terms, so since it has 4 terms, I'm going to try to use grouping. It's my initial thought when I look at it. It's got 4 terms, so grouping. 6 and 21 are both divisible by 3. They're both also divisible by m squared, so I can pull out a 3 and an m squared from both of these terms. That leaves me with 2m minus 7. And of course I mentally distribute back in. 3m squared times 2m is 6m cubed, okay? And 3m squared times negative 7 is negative 21m squared. Okay, good. Now on the right-hand side, I don't have anything to factor out, right? So since I don't have anything, I can factor out a positive 1, leaving me with 2m minus 7 in here. Then I have my outside stuff, 3m squared plus 1. And I've got my inside stuff, this guy and this guy. They're identical. And that's 2m minus 7. And that is fully factored. Question 4 is just like that. 4 terms. These are both divisible by 2. So 2 and b squared. That can come out. Leave me with 6, nope. Leave me with 3b minus 2. Yeah, mentally distribute back in. Yep, correct. On the right-hand side, 21 and 14 are both divisible by positive 7. So this leaves me with 3b minus 2. And my outside stuff can be combined into a single bubble. 2b squared plus 7. And my inside stuff is my other bubble, 3b minus 2, and that is my fully factored answer. Question number 5 does not look like that, so I'm going to mentally follow my flow chart. You can find it earlier on one of the previous lessons. First thing I check is a GCF. Is there a GCF? Yes, there is. They're both divisible by 3. So I factor out a 3 from both. I get 3n squared minus 9. And then I acknowledge that this is a dots, difference of 2 squares. These can both be square rooted, so I get n and 3, n and 3, it's a messy 3, and these are plus and minus. And of course the 3 comes along for the ride, so that would be my final answer, fully factored. This one looks to me like probably A&M factoring. Add to 8, multiply to negative 9. So let's see, negative 9 could be 9 times 1. If I made this positive, this negative, yes, those would multiply to negative 9, and they would add to 8. So this is going to become x plus 9, x minus 1. Identify the roots of the polynomial. My favorite way to do that is to try to do A&M factoring first. I always prefer to factor and then t-chart if I can, so let's see if that's possible. Things that multiply to negative 24. It's going to be 8 and 3, 12 and 2, 24 and 1, and 4 and 6. Now, because this term is negative, they got to add to a negative. I know that the bigger term is going to be negative. So let's see, which one of these will add to negative 5? I think it's this one. And will they multiply to negative 24? Yes, they will. Okay, so this is m minus 8, m plus 3. They want us to find the roots. That's the zeros. So that means our answers are 8 and negative 3. Question 8, identify the roots. Once again, I prefer to factor. I notice that these have a GCF of x squared, so I'll pull those both out to the front. X squared, leave me with x minus 5. I can set this equal to 0 because they want the roots. And I t-chart. This is going to be 5. That's easy. On the left side, if x squared equals 0, well, then I can square root both sides. Square and the square root will cancel. And get x is equal to positive or negative 0, which is the same thing, so x equals 0. Those are my two solutions. Question 9. I look for a GCF. Nope, there isn't one. Okay, and it's got 3 terms. It's got a number on the front, so that messes it up. I can't just do add and multiply factoring, double bubble. Can't do that. So what I'm going to do is these are A, B, and C. I'm going to do A times C factoring. So A times C is 18. Factors of 18 are 6 and 3, 9 and 2, 18 and 1. Now I want to find a pair that will add to 6. Well, let's see. None of those is going to work. And I'm sure it's positive 18. So that means these are both negative or both positive. So they've got to be both positive. Now this is where a lot of people got stuck. The thing is that just because we've been factoring and finding roots doesn't mean that that's the only way. We have 2 other ways. We have completing the square, and we also have the quadratic formula. That's not a Q. The quadratic formula. So in this case, I don't have anything else that I could do, so what I have to do is the quadratic formula. That's always a great backup. So still, these are A, B, and C. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So as I plug these in, I'm going to get, let's go orange, x equals negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 9 all over 2a, just 2 times 2. I can simplify what's underneath the radical all at once. I'm going to do it just in scratch work because I don't want to switch my calculator. That's 36 minus, 8 times 9 is 72, so this is negative 36. So when I clean this up a little bit, it's going to be x equals negative 6 plus or minus the square root of negative 36 over 4. Square root of negative 36 can be fixed in 2 ways. The negative can come out as an I, and then the square root of 36 is 6. So this can be rewritten, negative 6 plus or minus. Square root of 36 is 6, and the I comes along for the ride, all over 4. Now acknowledge that all 3 of these terms are divisible by 2. So if I divide them all by 2, I'll just draw slash 2, slash 2, slash 2, slash 2. That'll shrink the fraction to its simplest form, which is going to be negative 3 plus or minus 3i all over 4. No, it's not. It's 2. You could also have opted to split it, and you could have gotten negative 3 over 2 plus or minus 3i over 2. That would be fine as well. Either of those is a full credit answer, so no big. Almost done. Solve by completing the square. So we set it equal to 0. The steps for completing the square are to move the c term over, so minus 8 minus 8. I get m squared plus 2m, leave a space, is equal to negative 8. Now I take the b term, that's 2. I take it over to the sidebar. I divide it by 2, it's 1, and then I square that. 1. I take that number, and I add it back into both sides. Plus 1, plus 1. Now the left-hand side can be changed into a perfect square binomial. 2 things that add to 2 and multiply to 1. It's going to be m plus 1, which is m plus 1 squared. The right-hand side, let's bring all that down, is equal to negative 7. Now in order to solve for this m here, I got to get rid of the square root, the square with a square root. Now I get m plus 1 is equal to, well, remember this negative can come out, so I radical 7. And last, but possibly most importantly, minus the 1 over to get the m really by itself. And I get m is equal to negative 1 plus or minus, remember we added the radicals, so that put a plus or minus here. Negative 1 plus or minus I radical 7. And that would be my solution for that one. What does the discriminant say about the roots of the following function? So we had a table about this, right? We had that a positive discriminant means 2 roots. We had that a 0 discriminant meant 1 root. And we had that a negative meant that the roots were imaginary. The discriminant is the part of the quadratic formula underneath the radical. The discriminant is b squared minus 4ac. So here's what I'm going to do. I'm going to identify a, b, and c. A, b is negative 1, c is negative 4. I'm going to plug those into the discriminant. So negative 1 squared minus 4 times negative 6 times negative 4, because that's c. This is going to be equal to 1 minus 16 times 6 is 96. 1 minus 96 is equal to negative 95. Okay, so that means that these are imaginary roots. For the second one, same thing, b squared minus 4ac. So a, b, c. Yeah, okay, cool. Just making sure I didn't make any algebraic mistakes, lead you the wrong way. So b squared is going to be negative 4 squared minus 4 times a, which is negative 4, times c, which is 2. Negative 4 squared is 16, minus 4 times 4 times 2. So it's going to be plus 32. This is 48. Now, that is positive, so that means we have 2 real roots. Last but not least, A, B, C. Let me switch color, going back to orange. A, B, and C. So B squared, that's 8 squared minus 4 times A times C. Now, 8 squared is 64, minus, well, this is going to be plus, no, triple negative, back to minus. 4 and 2 is 8, 8 is 64. 64 minus 64 is 0. So that means that these roots are 1 real root. And just because I can, I'll show you guys what I mean by these, right? It means that if I graph this first one in red, right, it's a negative, so it would be a frown, like this. It would not touch the x-axis at all. And I don't really care where the y-axis is, whatever. For the middle one, the green one, okay, this has 2 real roots. What that means is, once again, this is a frown because it's got a negative coefficient on the biggest term. That means it's going to hit twice, and we're going to be able to see those hit points. And for the last one, the orange one, 1 real root means that it touches in one place, one spot, and it turns right back around. So that's what that looks like. I'll do the bonus, but there is no bonus on a retake, so it's not really important. Factor and find the roots of the following polynomial. It's got 4 terms, so I see it as grouping. I'm going to pull out a 3 from the first one, leaving me with 3, or rather I'm going to pull out a 3x squared. Leave me with 3x plus 7. The next one, I'm going to pull out a positive 27, leaving me with 3x plus 7. I combine my outside stuff, 3x squared plus 27. and 3x plus 7. I notice that there's a GCF here, so I'm going to pull it out to the front. 3, leaving me with x squared plus 9. 3x plus 7. And it says to factor and find the roots. So if I'm going to find the roots, that means set it equal to 0 and t-chart it. 3x plus 7 equals 0. I'm going to minus 7 because I'm trying to get x by itself. 3x is equal to negative 7, and divide by 3 on both sides. X is equal to negative 7 over 3. That's going to be one of my roots. Now I don't care about this 3. It doesn't even have an x in it. So I only care about the x squared plus 9. Set it equal to 0, minus 9 on both sides. I get x squared is equal to negative 9. And I have to square root to get rid of the square on the x. Square and the square root cancel. X is equal to positive or negative. Square root of a negative. So negative comes out as an I. And the square root of 9 is actually 3. So I'll just rearrange this order. 3i. So it's my 3 roots. Plus or minus 3i. That's 2 different roots. Those are imaginary. And 1 real root, negative 7 over 3. Okay, cool. I hope that was helpful. Good luck. See you tomorrow.